Hello class, today we're going to cover section 6.3, the ellipse. And one of the things important about the ellipse is that unlike the parabola, which has one focus point, the ellipse has two. And what makes a ellipse so unique is that the distance to any one point on the ellipse from the two focal points, their distances added up, so like this and this, is the same for any point that we use. So if I had created another point, let's say over here, let me use a color. If I took the distance from here to here plus the distance from here to here, that would be the same as the green that I had highlighted. And that's the unique thing there. Now, since this thing is elongated along the x-axis, that would be known as the major axis, which is something important. And the minor axis would be the y-axis. So, talking about that, there's a theorem for when the x-axis is the major axis and the center of the ellipse is at the origin. The foci, or the focal points, the C for the focal point is going to be the x-coordinate for the focus, and the vertices is going to give you my A. So when we look at this problem here, I'm going to go ahead and graph it, and it tells me, all right, the center's at the origin, the focal point is at 3, 0, and so if the focal point, in fact, let me do that in a different color. The focal point's at 3, 0, so it should also be at negative 3, 0 because we have symmetry. The vertex is at 4, 0, and so that also means that it should be, it's at negative 4, 0. It should also be at 4, 0. Now to find out what the, and so this makes it the major axis. So to find the minor axes, what we're going to do is we're going to take the formula of b squared is equal to a squared minus c squared. And so we see that the c comes from the focal point. So if one focus is at 3, 0, that should be my c. So I see that c is equal to 3. And the a is found from the vertex, and so we see that a here is going to be 4. And these numbers are going to always be positive. So then using those numbers, we're going to go see what b is. And so b is going to be b squared is equal to 16 minus 9. So b squared is equal to 7. So b is equal to plus or minus the square root of 7. Now when we write the formula for it, we're going to get x squared over 16 plus y squared over 7 is equal to 1. That's our formula. This is kind of a big deal. And then what we know is then square root of 7 is going to be our minor axes. And so the minor axes is going to be something around there and there. And so we're going to connect these dots. Bear with my terrible drawing. But there is my ellipse, and this is how we do it. Let me show you another example, kind of doing it from a different format. So if I give you something like this, what we end up seeing is it's pretty cool. So we see that the major axis is going to be the x-axis, and the reason we know that is because the 25 is bigger than the 9, and that's along x. So I know that since the center is at the origin, plus and minus 5 are going to be the major axes points, and then the square root of 9 is 3. So it's going to be plus and minus 3 for those points. And so my ellipse is going to be this. But we need to find the focal point, or the two focal points. So we're going to go c squared is equal to a squared minus b squared. And what we end up seeing is we're going to get c squared is equal to 25 minus 9. So then c squared is equal to 16. So c is equal to plus or minus 4. And so I'll do that in a different color. The focal points are at plus and minus 4. This guy and this guy, they are the foci, and this is the major axis. Okay, now when we have y as the major axis, here's what the theorem looks like. Again, the only difference is instead of having x coordinates, the c and the a are found from the y coordinates. And so we're going to have to manipulate this one a little bit to make it look like an ellipse. So what I'm going to do is I'm going to divide everything by 9. And now I have my equation of an ellipse. To be able to find my c, I'm going to go c squared is equal to my a squared minus b squared. So c squared is going to be equal to 9 minus 1, or c squared is equal to 8, or c is equal to plus or minus 2 radical 2. And again, since the major axes here on this one, the major axis is the y-axis. This is going to be coordinates of 0, 2 radical 2, and 0, negative 2 radical 2 along the y-axis. So let's go ahead and graph this. So again, I'll rewrite the formula. So it's x squared over 1 plus y squared over 9 is equal to 1. And since the origin is the center, y is going to be 3 away. So 1, 2, 3. 1, 2, 3. And we can see that the x has a distance of 1. So our ellipse is this little thing. And we have to find the foci, and we said that the foci was at plus or minus 2 radical 2. So that's almost at 3, and I'll do that in orange. And that is the foci. Now, the y-axis here is the major axis for this guy, because again, it's elongated along the y-axis. All right, here's another example. So again, we can see that this one, its major axis is in the y because the focus and the vertices, the major vertices are along y, but this really is always going to tell us which is the major axis. Since the focus is along the y, this is going to be something that is major axis is the y-axis. Now, since the focus is at 2, it's at plus and minus 2, and the vertices, I should do those in orange. And the major axes, vertices are at plus and minus 3. So in order to be able to graph this thing, we have to find out what our minor axis is. And so we're going to go b squared is equal to a squared minus c squared. So b squared is equal to 9 minus 4. So b squared is equal to 5. And we're going to get b is equal to plus or minus the square root of 5. And square root of 5 is just beyond 2. Just beyond 2. And so this is what our ellipse looks like. And the equation that we're going to be given is going to be x squared over 5 plus y squared over 9 is equal to 1. Now here's some information for you when we are no longer at the origin for our vertices. You may want to pause and write these down. This is something that can be useful for you to use. And one of them has the major axes with the x-axis, and the other has it with the major axis at the y-axis. So let's go ahead and do a problem where we have a little bit of a shift. Here's this example. So this is now my h and my k, because that's the center. We're given a focus and a vertex. So I'm going to go ahead and plot these just so you can see. So 2, -3 is this point right here. And then it tells me that the focus is at 3, -3. So that tells me right off the bat, it's got a distance of 1 away from the center. So my major axis is parallel to the x-axis. The vertex is going to occur at 5. Ooh, I should have made the focal points a little bit consistent with the orange. And then the focal, or the vertex, is at 5, -3. 5, -3. And since it's at 5, -3, we're also going to have a solution on the other side, and that's going to be, it's 3 away, right? So that's 1, 2, 3. So I should go 1, 2, 3. So here is the other focal point. I'm just trying to show you guys how I would graph this thing. And now from here, what I have to do is I've got to be able to find my y. And so my y is going to be b squared is equal to a squared minus c squared. So b squared is equal to 9 minus 1. And the way I got that, just so you guys know, my a is the distance from the center to the vertex. So that's a distance of 3. And my distance to c is from foci to center, and that's a distance of 1. So this is my c, this is my, I'm sorry, I wrote those backwards. This is my a, this is my c, and that's how I found them graphically. Now to find my b, I'm going to get b squared is equal to 8. So b is equal to plus or minus 2 radical 2. And so that's about there. And so my ellipse is going to look something like this. Now, this 2 radical 2, what you're doing with that point is you're adding, and it's important that I point this out, this gap distance is 2 radical 2. So to get the minor vertex point, you'd have to add 2 radical 2 to the center value for y. So you'd have to add it to this 3. Does that make sense? So I'd have -3 plus 2 radical 2, and then I'd have -3 minus 2 radical 2. And those would be the y values for the vertices along the y-axis, the minor axis. Now the equation for this thing is kind of simple. It's x minus 2, just like we've done in the past, over the distance from the center to the x vertices, which was 3 squared, so that's 9, plus or y plus 3 over my b squared, and then equal to 1. And that's my equation for this graph. All right, so let's do another example where we have to do a different technique to it. And so for this one, what we're going to do is we're going to have to complete the square. So I'm going to rewrite this so it looks, and it's written in a way that's beneficial for what I'm trying to do. Oops, there's no 4 there. I'm basically grouping things, and then the constant's going to go to the other side, so it's going to be a negative. So what I'm going to do is I'm going to pull out a 4 and get x squared minus 2x, and then I'm going to complete the square. So I'm going to take half of 2 and then square it. So that's going to give me that. I'm going to complete the square for this. So half of 4 is 2, squared is 4. And so I'm going to get negative 4. And what I did is I added 4 for completing the square of this first part right here. And then I'm going to add 4 for this second part right here. Because see how I added the 4 there? So I added 4 twice. And the reason I added 4 the first time is because it's the 4 times that plus 1. So then I'm going to factor these things. So I'm going to get 4 and then x minus 1, that quantity squared, plus y plus 2, that quantity squared, and that's going to be equal to 4. Now, in order to make it an ellipse, I'm going to divide everything by the coefficient of the 4 in front of the x minus 1 squared. So I'm going to get x minus 1 squared over 1 plus y plus 2 squared over 4, and then equal to 1. So this is really beneficial because now we can see that the center of this thing is at 1, negative 2. So if this is the x-axis, this is the y-axis. 1, negative 2 is right here. We can see that the distance along the x is going to be 1 to the right and left. And the distance for the y is going to be 2 above and below. And so the ellipse is going to look like this. That's what the ellipse looks like. And then what we should do is go look for the foci. And so the foci are found by going c squared is equal to a squared minus b squared, or 4 minus 1. And so c is equal to plus or minus the square root of 3. And so adding, that's like 1.73 being added to both sides. And so that's about there and there. And that is where our focal points are. I hope you found this beneficial. As always, all the best.